36, then variation is of cubic parabolic nature. The important point to be noted over here, that shear force is 0 is between C and B. So this cubic parabolic nature, but the ordinates are, it is always below 36. Sudden change is over here at a point where concentrated moment is acting, and because of this UDL parabolic nature of the diagram we can obtain. The important thing which you will note it down over here, the maximum bending moment is taken care at 1.8 distance from B, and we can achieve it is of 16.4 kilonewton into meter, and the whole diagram is under positive sign. I wish you will understand this fundamental clearly, and let us go with the next one typical problem. So in this series number 1 we solved numbers of problems for statically determinate beam, but specifically the beam is of simply supported beam. Now let us take one typical problem over here, and let us plot the shear force and bending moment diagram. Carefully visualized, 1, 2 and 3 supports has been given to us. So at the prima facie we understood the given beam is not a statically determinate beam at the initial stage. But important thing is that at joint B over here internal hinge is given to us. Internal hinge. This internal hinge gives an additional degree of freedom. Additional equations gives us that bending moment at this particular joint at this point is 0. So I can modify this figure right now like this. The given beam is of this nature. (4 meter). Then here the internal hinge is given. I will write down the name, internal hinge. This is of 2 meter and this is of 2 meter. B, C and D. Right now I am not going to put any kind of load, but let me simplify this figure so that it will look like statically determinate beam. Hinge, the forces are acting at hinge. So if I will give it as RA, this is my RB, RC and RD. So clearly visualize, I have divided my beam into two different parts at joint B. This is upward reaction RB. So this beam is of simply supported. This RB acting as a point load over here, and this beam is of overhanging beam. So now because of the internal hinge, I have divided my beam into the two different beams is of statically determinate nature, simply supported and cantilever. Now let us apply a load on this. Refer the figure. See, at this B, a hinge can transfer axial force and shear force but not bending moment. So bending moment at the hinge location is 0. This is an additional equations given by this hinge. Also, without the hinge, the system is statically indeterminate of degree 1. So the hinge imposes an extra condition, thus rendering the system determinate. Now let us find out the support reactions. Simplifying this figure, reactions are B, reactions are B. So now sigma Fx or sigma H is equal to 0. Now comes to this particular point on this diagram. Let's simplify over here. The given beam is of simply supported. The given beam is of overhanging. Here the UDL is acting of 5 kilonewton per meter. Here the load, point load, which is of acting of 10 kilonewton at distance 1 meter from C as well as B. Now this is my RC, this is my RD. Clearly visualize over here, if we take these two different figure and act as a individually right now. Here in this figure, RB, RC, RD, 3 unknown, we cannot solve. So we have to take the first this figure. RA and RB are unknown, but there is no external forces acting over here. Straightforward. If you use RA, sigma H is 0, then this force RAH definitely 0, sigma V is equal to 0, RA plus RB is equal to 0, sigma M at any one point is equal to 0, then also we got RB is equal to 0 and RA is equal to 0 because no force is acting at all in this system. So this RB is equal to 0. Now the very simple, the given beam is of overhanging beam and our intention is to find out the support reaction. Then first equation, RC plus RD is equal to 10 plus 5 into 4, that is equal to 30 kilonewton. Now taking a moment at D, we will be able to find RC, or taking a moment at C, we are able to find out RD. Let us find out over here. Take the moment at D. Let us take a moment at this point D. So VHU, by taking all the moments of the forces at point D, VHU RC as is equal to 22.5 kilonewton and RD as 7.5 kilonewton. So now let us go for the shear force and bending moment diagram. This is the internal hinge, application of point load. This is the UDL which is acting. Baseline. Reactions are known to us. The value of RC comes to be 22.5, RD comes to be 7.5. This is of 10, 5 kilonewton per meter. So 0. So our diagram, let us use, if I will use the another color pen, 0, 0. No load is there, no reaction is there. So the shear force up till now this point is 0. At this point the stand load is acting, section it is acting downward. So downward 10 is acting over here. Now there is no load between this point, horizontal straight line. Now this 10 downward plus 22.5, so minus 10 plus 22.5, we achieve 12.5 upward plus sign. 12.5. UDL is there, variation of inclined straight line, value RB 7.5. Join this two line by inclined straight line. Very simple. This is our shear force diagram. Minus sign, plus sign, minus sign, and find out this distance or this distance to achieve maximum value of shear force, because at this point the value of shear force is 0. See this figure over here. This distance we come across is 1.5. So please see on this distance is of 1.5. How to achieve 1.5? I assume you know it very well, because we have solved numbers of numericals based on this. Now let us go ahead with the next one, plotting of bending moment diagram. Now there is no load over here in this region up till point this, so the variation of bending moment diagrams is also becomes 0. As when reach at this point, once again bending moment is 0, but if we go afterwards, the value of bending moment diagram changes between, this is point A, B, C, D, and if I will take this point as a E, so between E and C there is no load is there, so variation of bending moment diagram is given by, yes, inclined straight line. So this distance is of 1 meter, this distance is of 1 meter, 10 into 1 we achieve by inclined straight line 10 with minus sign. Now this is the ordinate where we get maximum value of bending moment. So at this point, end of the support, the value is 0. UDL is given to us, the variation is given by parabola. This is the ordinate that we have to find out. Now let us we found out this ordinate, because this is 1.5, then this will be of 2.5. Then in that case, maximum bending moment is equal to minus 10 into 1 plus 2.5 plus 22.5 multiply by 2.5 minus 5 into 2.5 into 2.5 by 2. 5 into 2.5 is the total load into 2.5 by 2. So we achieve Mx with this is equal to 5.625 kilonewton into meter plus sign. would like to explain you the concept of this in the next session. What is this? But would like to explain you briefly. The point at which bending moment diagram changes its sign from minus to plus or plus to minus is known as point of contraflexion. Other word is point of inflation. How to find out? We will discuss the next class. What is the importance of this point? We will discuss in the next class. So now, refine this PPT. This is the variation of bending moment diagram for this particular given figure. So, in this series 1, we understood the support calculation of support reaction. We have introduction to the shear force and bending moment diagram, and we have solved numbers of problems related to the simply supported beam. And with the inclusion of all kinds of variation of loadings, including internal hinge also. I wish now you can solve more numbers of problems for simply supported beam. In the next series, we are going for a cantilever beam. How the cantilever beam will behave under the point load, under the uniformly distributed load, under the uniformly varying load. Also concentrated moment, that we will discuss in the next session. Thank you.